Hi everyone, in the previous lecture we have discussed the concept of derivatives. In this lecture we will be discussing the algebra of derivatives. Algebra means when we are given with the sum of two functions like fx plus gx, or we will be given with the difference of two function fx minus gx, and likewise the product and the quotient of two functions. Then how do we do the derivatives of these function? We will discuss that here. So rule number one, if we are given with the sum of two functions like f plus g and we have to find derivative of the sum of the functions, then we can individually find their derivatives, like the derivative of f and derivative of g. If we are given with the sum, then we will find their sum, or we will add them together. If we are given with the difference, then we will be putting the difference. We will be finding the difference, or we will putting the negative sign here. So for example, if we are given with fx is equals to x raised to the power 5 plus sine x. So as you can see that f is a function of the sum of two functions like x raised to the power 5 and sine x. So the derivative of fx will be derivative of x raised to the power 5 individually plus derivative of sine x. As we know that the derivative of x raised to the power n is equals to n x raised to the power n minus 1, and the derivative of sine x is equals to cos x. So applying these, we will be having derivative of x raised to the power 5 will be 5x raised to the power 4, and the derivative of sine x will be cos of x. So the derivative of fx is equals to 5x raised to the power 4 plus cos x. Okay, we have find the derivatives together. Suppose this x raised to the power 5 is another function gx, and hx is equals to sine x. So gx is equals to x raised to the power 5, hx is equals to sine x. So derivative of gx will be 5x raised to the power 4, and the derivative of sine x will be cos of x. What we are given with, we have to find the derivative of the sum of the functions, so it will be 5x raised to the power 4 plus of cos x. That is our ultimate derivative. So like here we are given with the function x raised to the power 5 plus x raised to the power 3. So we will be finding their derivatives individually. So derivative of x raised to the power 5 will be 5x raised to the power 4, and derivative of x cube will be 3x square. So the next example is for gx is equals to x raised to the power 7 minus e raised to the power x plus sine x minus x plus 5. We will be differentiating each function individually. So derivative of x raised to the power 7 will be 7x raised to the power 6 minus e raised to the power x. So the derivative of e raised to the power x is e raised to the power x itself, so there will be no change. We'll put in the same here. And the derivative of sine x is cos x, and derivative of x is 1, and the derivative of constant is 0. I have solved the problem directly. We can also do like this. So the derivative of gx will be derivative of x raised to the power 7 minus derivative of e raised to the power x plus derivative of sine x minus derivative of x plus derivative of 5 with respect to x. As we have discussed, derivative of x raised to the power 7 will be 7x raised to the power 6, derivative of e raised to the power x is e raised to the power x, and we have a negative sign here, so it will be negative of e raised to the power x, and so on. So this will be our final answer. We have another rule. If we are given with a function and that has a coefficient along with that, that means af, or we can say that it has a multiple, so its derivative will be, we do nothing with a and find the derivative of the function only f. Likewise, if I am given with 2 sine x. So its derivative will be 2 times derivative of sine x alone. So it will be 2 times cos x. As we have discussed the derivative of 2 sine x, so here in the example fx is equals to 3 sine x, the derivative will be 3 times cos x. In the next example, gx is equals to 7 e raised to the power x. So g dash x will be, or the derivative of gx will be 7 times derivative of e raised to the power x, and we know that derivative of e raised to the power x is e raised to the power x itself. So the derivative of the function g will be 7 e raised to the power x. Likewise, here we have function, suppose h. So derivative of hx will be derivative of 5x cube. Let's write it like here. We have a constant here. We will be putting that aside and we will be just finding the derivative of x raised to the power 3. So it will be 5 times derivative of x raised to the power 3 will give you 3x squared. So it will be 15 times x square, or 15x square. Firstly, in the first rule we were given with the sum of two function f and g. Suppose they have some coefficient like a, f and bg, and we have to find their derivative. So it will be a f dash means derivative of f, plus b g dash, or it can be expressed it like that. Suppose we have a fx plus b gx, that is our function, and we have to find the derivative, or we can say that d over dx. So the derivative will be a d over dx fx plus b, we will leave that aside, b d over dx gx. If we have negative here, so it will be a negative here too. As we have discussed, for the sum or difference of two functions, it can be more than 2. Like here in example, fx is equals to 2x cube minus 3x square plus 7x plus 5. We can easily find its derivative. Fx is equals to 2x cube minus 3x square plus 7x plus 5. So its derivative will be d over dx fx will be 2 times derivative of x cube minus 3 times derivative of x square plus 7 times derivative of x plus derivative of 5. Here we can see that in 2x cube minus 3x square plus 7x and 5, 2 minus 3 and 7 are coefficient. We don't mess with them and we find the derivative of the functions only. So it will be 2 times derivative of x cube will be 3x square minus 3 times square of derivative of x square will be 2x plus 7 times 1, and derivative of 5 is 0, as 5 is a constant, its derivative will be 0. So our answer will be 6x square minus 6x plus 7. Till now we have discussed derivatives of the sum of the function and the difference of the function. Now we have product of the function. We have two functions f and g, and we have their product. Like if we are given with x sine x, x is an algebraic function, sine x is a trigonometric function. So when we try to find derivative of this type of function, we don't do like this, that derivative of x is 1 and derivative of sine x is cos x. Our derivative of x sine x will be cos x only. No, we don't do like this. What we do is, when we have product of two function f and g, so the derivative of the product of the function will be f dash x times gx. At once we derivate only one of them. Now we have derivated the function f. Now we will be leaving that aside fx and we will derivate the next one, that is g. So we can say that if we have f into g and we have to find their product, so it will be f dash g plus fg dash. What I used to do is I write two functions fx and gx, I find their derivative and cross multiply it. After cross multiplying, I will be getting fx times g dash x and f dash x times gx, and then add them. So we will be getting the same. Here derivative of f times g is f dash g plus fg dash. In the example that I have given here, x sin x, what we will be doing is we will derivate the first function first, x, and we will leave the sin x as it is, plus now we are done with the derivative of x, so we will leave that here x, and we will derivate the second function. So sin x derivative of x is 1 plus x derivative of sin x is cos x, so it will be sin x plus x cos x. Let's have an example. For fx, x is equals to x log x or x ln x. So we have two functions x and ln x. We have to find the derivative of their product. So it will be ln x times derivative of x plus x times derivative of ln x. So it will be ln x times derivative of x is 1 plus x derivative of ln x is 1 over x. So x cancel each other, so it will be ln x plus 1. As I have discussed the earlier approach, what we do is, so derivative of x square is 2x and derivative of e raised to the power x is x. Now I will be cross multiplying, so it will be x square e raised to the power x plus 2x e raised to the power x. That is our derivative for x square e raised to the power x. Let's try one more time. So derivative of 2x cube will be 2 times 3x square, that is 6x square, and derivative of cos x is negative of sin x. By having their cross product, we have minus of 2x cube sin x and 6x square cos x. We put a plus sign here, and that is the derivative of our hx. So we can say that h dash x is equals to minus 2x cube sin x plus 6x square cos x. The next rule we have is for the quotient of f and g. So what we do is, first we square the denominator part. The numerator will be like that we have done in the product rule. It will be f dash g, and we have to note that we don't have plus here, we have a negative or minus here. Okay, so we have to find their difference. F g dash. For example, here we are given it fx is equals to x cube over sin x. So what we do is, when we derivate it, the first thing we do is we square the denominator, so it will be sin square x. And now in the product rule, order doesn't matter because we have a plus here. We have to find their sum, so we can take them in any order. We can write like 6x square cos x minus 2x cube sin x, both will give you. But here we have to note that we have difference here, so we have to differentiate the numerator first. So it will be sin x d over dx x cube minus x cube. Now we will differentiate the denominator, that is sin x. So it will give you sin x into the derivative of x cube will be 3x square minus x cube derivative of sin x is cos x over sin x square, or we can say that sin square x. So our answer will be 3x square sin x minus x cubed cos x over sine square x. We can also further simplify it like 3x squared sine x over sine square x minus x cube cos x over sine square x. This sine square x will cancel exponent of sine x, so we'll be having 3x square 1 over sine x is cosec x minus here x cube cos x over sine x is cot x, and we are left with sine in the denominator. That means we will be having a cosec x here. We don't have to do that, we can leave our answer till here, and that is totally fine. In the next example, we have a function h, that is x cube minus 5x over x square plus 1. So as we discussed, what we do first, we square the denominator part, that will square of x square plus 1, and we differentiate the numerator first, so it will be x square plus 1 times derivative of x cube minus 5x minus, we are done with the derivative of first part, so x cube minus 5x will be as it is, and we will be differentiating the second part, that is x square plus 1. So h dash x will be x square plus 1 times the derivative of x cube minus 5x will be 3x square minus 5 minus x cube minus 5x, and the derivative of x square plus 1 will be 2x, and as the derivative of constant is 0, so we will be differentiating the x square only, so it will be 2x, and in the denominator what we have, square of x square plus 1 using the formula of squares of sum, so we will be having x raised to the power 4 plus 2x square plus 1 in the denominator. Okay, we are done with the derivative part. Now what we have to do is we have to simplify. As we have discussed, we use quotient rule when we are given with the quotient of two function fx and gx, but sometimes we can easily convert into an algebraic function in normal polynomial function, and we can solve it directly. As we have discussed that we can use quotient method. The first method that we can use is the quotient rule, and that will give you the answer. But in the second rule, we can modify it by expanding, like x cube minus 2x plus 1 over x as x cube over x minus 2x over x plus 1 over x. So it will be equals to x square minus 2 plus 1 over x, or x raised to the power minus 1. Now we can easily differentiate it. The derivative of the function f will be derivative of x square minus 2 times derivative of 1 plus derivative of 1 over x. So derivative of x square will be 2x, and the derivative of constant is 0, so it will be 0, and derivative of 1 over x is minus 1 over x square. If you have doubt with derivative of 1 over x square, as we have discussed that 1 over x can be written as x raised to the power of minus 1, so we can derivate it here. So using the formula of derivative of x raised to the power n, so it will be minus 1 x raised to the power minus 1 will be minus 2, so it will be minus 1 over x square. So the derivative of f will be 2x minus 1 over x square, and if we take LCM, so it will be x square and it will be 2x cube minus 1. That is the same. As you can see, both the method gives the same answer, the exact answer, so we can use any of these. So if you are given with a function that is in quotient form f over g, you can check whether it can be expressed in an algebraic form or not. If it is, we can easily find its derivative. Next rule is chain rule. Chain rule is used to find derivative of composite function. If you are unaware of composite function, let me tell you. In composite function, one function is the function of another function. Like in conventional function we have fx, means the function is directly influenced by the value of x. But in composite function we have something like sine of 2x. Here as we can see that sine is a function, but it is not directly the function of the independent variable, it is the function of 2x. Whatever the values the function 2x gives, sine works upon that. So we can see that here fx is sine x and gx is equals to 2x. So we can say that f of gx means when we give an input x, first it will go to the function gx will do its work, and then its value will go into the function f. So in chain rule, when we are given with a composite function, we can easily replace the second function by ux. Means if I have sine of 2x, I can replace the 2x by u and simply differentiate it. So when I differentiate, it will give you a cos u. But what I have to do is, I have replaced this 2x by u, so I will be having a derivative of this u, so it will give you a 2 and then multiply here by 2. When we are given with a function like a composite function, f is the function of another function ux, and we have to find its derivative. So what we do is, we differentiate the function f as normal as we do. So it will be f dash of ux and we multiply by the derivative of u. Like here in sine 2x, this is our ux. Okay, so the derivative, what we have to find derivative of sine here. So derivative of sine is cos and it is a function of 2x, so we'll be writing 2x here, and again, and when we differentiate 2x we will be having 2, so our answer will be 2 times cos of 2x. In the simple word, chain rule says that if we replace x, means if we replace x by another function u, so what you will do is, we derivate the above the same, like sin x will be cos x, and again we will multiply the function by the derivative of u. Let's have a function like sin u. Now sin is a function of another function u, or we can say that sin is the function of u, and we have to differentiate along x. We can differentiate only and only if the function is along the same variable. So the derivative of sin u will be cos u times u dash. So dy dx ln u will be 1 by u. Derivative of log x is 1 over x, so log u will be 1 over u, and the derivative of u. The composite function f of gx is like an onion peel. We have to differentiate each layer or each function until we get to the x, or the independent variable. Like if I am given with e raised to the power sine x square. So the first function we have e, then we have sine, then we have x square. So what we do is, we differentiate this function e, that will give you the same answer. Suppose this is the function f, so its derivative will be f dash. So derivative of ex is ex. We don't care whether it is the function of x or another function. If e is the function of x, so we will be writing x. Here e is the function of sine x square, so we will be putting sine x square. Then we differentiate it sine x square, or we multiply by the derivative of sine x square. Now as we can see that sine is not direct function of x, it is a function of x square. So again we will be having chain rule here. Here as we can see that the first function is sine, not x square, because sine is the function of x square, so we will be differentiating it first. So it will be, sine will give you cos, and it will be a function of x square, not x, and we will be again differentiating x square. Here x square is the function of x, that means this is the final step, and when we differentiate x square we will be having 2x. So our answer will be 2x e raised to the power sine x square cos x square. Let's have some example. In the first example, fx is equals to sine 2x square plus 3. Here we can replace this 2x square plus 3 by u. So it will give you cos u times derivative of u, that is d over dx 2x square plus 3. So putting the value of u, so it will be cos of 2x square plus 3 times square of 2x square will be 2 2s are 4x plus 0. So it will be 4x times cos of 2x square plus 3. Let's have another example. Fx is equals to e raised to the power 5x plus 3. So replace this 5x plus 3 with u. So the derivative f dash x will be derivative of e raised to the power u. So it will give you e raised to the power u times derivative of u with respect to x. So it will be e raised to the power u times derivative of 5x plus 3. Derivative of 5x plus 3 will give you a value of 5, and e raised to the power u will be 5x plus 3. Likewise, when we differentiate this function, so it will give you e raised to the power sine x, as the derivative of exponential function is same. So derivative of e raised to the power sine x is e raised to the power sine x. But here, as we can see, that e is not the function of x itself, it is the function of sine x. So we'll be multiplying with the derivative of sine x. And here sine is the function of x, so we will be terminating our chain here. So the answer will be e raised to the power sine x times derivative of sine x is cos x. In the next example, we have a function f, that is ln x square plus 4. So let's replace, or let's substitute u is equals to x square plus 4. So f dash x will be derivative of ln u, and that will give you 1 over u times derivative of u. So on putting the value of u in the expression, we will be having 1 over x square plus 4 times derivative of x square plus 4. So it will be 1 over x square plus 4. The derivative of x square plus 4 will be 2x. So our answer will be 2x over x square plus 4. Hope all the concepts are clear to you. If you have any query, please contact on the provided number or mail us at info@ivclasses.com.